Hello and welcome to the video. Merge sort, a sorting technique, and here we need to find counting inversion. This particular problem is in sorting section in the series hackerrank interview preparation kit, and I think this is the first problem which has a difficulty of hard in the series, and we'll surely solve it. And I'll try to make as simple as possible. In order to solve this particular problem, we need two basic prerequisites. That is a merge sort and knowing what is the inversion. That is what we are going to count. So merge sort is a basically a divide and conquer strategy or algorithm. In this sorting technique, what we do is we divide the given array into half, then divide it to further till we get the single element. And single elements are naturally or by definition are already sorted, and after getting the single elements we merge them with each other, and we get the sorted array. So that is the merge sort. I'll surely explain that in coming minutes. And what is the inversion? Inversion is something whenever a large number appears in front of a smaller number. So in given array, if the given array is not in ascending order, and by any chance if let's say 4 is a number and that comes in front of like 1 or 2, in any between after the fourth position, so that is the inversion, and we need to count inversion pairs. So 4 1 4 2, that are the pairs. So that is the inversion, and I had made a video. I'll add the link in the description or in the cards. I'm not sure how will I do that. So but I'll add a link where I discuss the counting inversion. So basically there are the three techniques which we predominantly use. So first one is like using the insertion sorts algorithm or bubble sorts algorithm. So that works in O of n square. So we basically compare all the elements and then calculate the what we call inversion pairs. Second one is the merge sort, and I because this is a large program and requires quite bit of knowledge, so at that time I did not cover that. And the third technique was using a cell balance string. So cell balancing tree can be implemented using set, and set by nature are in the ascending order or sorted order. So what we can basically do is insert element to set and then check the distance between that element and the upper bound. So that will basically give us the counting inversion or the inversion number. So that is the case, and I specifically did not want to do a merge sort, like counting inversion using merge sort there, but because it's explicitly written here that counting inversion using a merge sort, we have to cover this. So this is the basic like prerequisites which we should know before going into the problem. So I think this particular video will be too long, or I would be making a two-part series, because so many things are being involved: merge sort and then inversion. And merge sort problem itself has like I think 80-90 lines of code, even if you do optimization, but to a simpler level. So that is the thing. So in the end of the video I'll be letting you know, like if the video length is too long, that's one video. If it's a shorter, let's say 20 minutes, so that would be like a two series video. So let's start. So what is a merge sort? I'll go with the detailed explanation, and after that we'll be counting number of inversions. So let me start. So let's take any random numbers. So let's start. So let's take a random number, let's say 4 1 2 here and 3 here. So let's say this is the given array and we need to sort this particular array. So by the definition we know that merge sort is a divide and conquer strategy. So I'll be noting things here which we need to do, or which we need to keep in mind. So first is divide, so or making it into the equal half. So this is the first thing which we need to do. Okay, so how will we divide this? So let's say, because this is the even array, we'll get the mid at this position. So there will be two parts, two equal parts to be precise, and they will be divided. So let me redraw them. So this here at this particular position will have an array with 4 and 1 in it, and here I will be having 2 and 3. So this is the first step. Okay, after this we want to divide our array till we get the single element. So we'll further divide it. So after further division, it will become a single element, that is a 4, single element 1, again here it will be 2 and 3. Okay, so first one was divide. So let me draw a line here so we can keep the notes on the right side. That will ensure or that will help while writing code. So second, we want to divide it till we get the single element. So that particular statement means we will use recursion and will go as long as we will get the single elements. Okay, so this, let's say this is the second thing which we need to keep in mind. After doing this, okay, by now we have saw what is called a divide or getting the value to the single element. So that was the dividation part. So we can see that there were two divisions. So for the first half, then for the second half, again for the first half, then second half, first half, second half. So what we are actually doing is we are calling the function recursively two times. So let's say if our function is a merge sort. So we are basically calling merge sort for the left part and the merge sort for the right part. Okay, and then dividing it to the further till we get the single element. So how we can get how we are at the single element position or not. So we can simply check its position. So if the first position, let's say left, and the right position is the same, then that means it is at the single element. Or we can do it conversely as well. Whenever left is low than right, we are calling merge sort function. Whenever its condition is failed, it won't simply it won't call. Okay, so let's do that. Now all the division is done. The third stage is merging. So in the merging, we'll compare the values and then merge into the array. So let me do that. So third is a merge. So in the merge, what we do is we simply check 1 with the 4, and that will give us the value 1 and 4. So what is happening here is, and this is the important part because we are calculating number of inversion. So inversion is something whenever a big number is ahead of first one. So whenever we are comparing values and the first was the bigger value, so that is the inversion count. So as of now, let's complete the array or let's sort the array. After that, I'll cover whenever the inversion occurred. So this will become a not 4-1. I think I wrote it wrong. Let me recorrect. So this is basically 1-4. So we checked 4 with 1 and the 4 was larger. Hence we took the value 1 here and then 4 will be here. Similarly for this, because it is already sorted, so this will basically become 2-3 again, and here no inversion or no comparison occurs. So okay, so far so good. Let me take a different color. Okay, after this we'll merge these two values, and this is the where all the magic happens or it comes along. So I have so many memes about the merge sort. I'll show you in some time. So let's do this. So this is let's consider this as an auxiliary array or temporary array, and we'll get the sorted array here. We can simply return this temporary array to back to the main function, or we can copy this to our previous array and then return the original array as well. So let's do this. So here what will happen is, let's say we have pointer here. We'll check 1 with the first half first value to second half first value. So we'll check this value 1 with this value. So whichever is the lower will get its position into the temporary array. So 1 will be infixed here. So after this, what will happen is the pointer will change its position from here to here. Okay. So we'll check 4 with 2. So 2 is less, hence 2 will get its position. We'll again check 4 with 3. 3 is less, so 3 will get its position. And as of now, no members are left to be compared in the second half. So what we can do is we simply copy all the remaining elements in the first half. So there could be a possibility that this particular condition occur in the two halves as well. Like in the first, let's say for this particular problem, in the first hop there was an element which we cannot compare, and let's say for the generalization purpose there was n number of elements ahead which were 9, 10 or similar. So that would result into directly copying the elements into our given array. So that is the case which you need to like keep in mind. So as of now we got the sorted array, and let me check if I get a brighter color. Okay, so we saw a complete merge, and this is the fourth part, let's say a solution or the basic condition which we need to keep in mind. So I'll write a condition here. So I'll write all this condition while writing program. So these are the basic or the most important things which we need to keep in mind while writing the code. So let's count the inversion now, because that is the problem. So inversion happens whenever the larger number is ahead of the smaller one. So whenever a comparison will occur in our case, and after the comparison the swapping will take place or the rearranging of array, that is the inversion, where the inversion is happening. So we first compared 4 with 1 and then we switch their places. That means one conversion or one in. So I was saying inversion. I don't know how many times I have said conversion, but that's simply inversion. So one inversion is happening here, and I'm really sorry for that. So after this, the inversion will happen whenever we have the larger element, and then we'll compare with the smaller elements. So in this case, you can check we compared 4 with 2 ones, so that will be again one inversion, and after that we again compared 4 with value of 3, so that is again one inversion. So that basically for the given problem we have these many inversions, so that is a 3. And let me check with our common sense, that is our greatest friend. So how many inversion can take place? So 4 is the biggest value and rest of the array is sorted, so that means total number of inversion pairs which we can create are 3. So this is the whole logic, or how we can think in the terms of problem. So I think this is the enough for in order to like write the code, and let's write the code, because I think most of will be stuck there, because the logic building or the concept is very simple. We first take the array, we divide it till we get the single element. After getting the single element, we'll merge them, and while merging we'll simply count the number of inversions. So let me write the code for this. Give me a minute.